Our next lesson is on the topic of horizontal adaptive music. What is it? Simply put, it's a game audio technique that allows you to mix and match the sections of a song. You can change the order, and that allows you to prevent that song from becoming, or the form of that song from becoming stagnant. It's really a pretty simple idea, and I have a couple different demo events set up here in FMOD to hopefully make that clear and show you a couple different ways that you can approach using this technique in FMOD. First and foremost, what I have is not really a song, it's just more a series of different synthesizer waveforms. First a square wave, then a sine wave, then a sawtooth wave, and then lastly a noise wave. And they're just playing quarter note pulses at a tempo of 100 beats per minute. Not very interesting, not very musically satisfying, but great as an example for what we're going to do in this lesson, at least just to understand some of the basics. And the event that you see on the screen right now is kind of the beginnings of how to create a horizontal adaptive music system using markers in FMOD. To give you an idea of what I mean, we have a game parameter. The game parameter is basically just tied to these different waveforms. So let's start with square wave. And if I let that be our current state and hit play, FMOD is just going to allow this event to loop over this first bar and play that square wave continuously. And the reason it does that is because we have a transition marker right here that checks to see what the state of a current parameter is. The name of the parameter is waveform. It looks to see if that waveform is set to be square, and if it is, then it just simply sends it back to the square marker. I have the same thing here. We check two different parameters here. We check to see if the parameter is at the square wave or at the sine wave. Well, to give you an idea how this might work, let's change the parameter sine wave, start the playback from the beginning. And now our playback gets locked into this loop because when it hits this transition marker, it checks to see the value of the waveform parameter. It sees that that is set to sine wave. This says, well, if the parameter is sine, go to sine, it jumps it back to this marker, and it continues the loop here. I could allow this to continue, allow it to transition to sine, remain looped in sine, then change this parameter to square, and as soon as it hits that marker, it jumps back and then gets locked into this loop right here. So it's a pretty simple little logic system. And to give you an idea of how you build it, we've got two other waveforms here, so we can just go ahead and build this up, and you can see how to put this together on your own. The first thing we'll start with, if we right-click up here in our logic track section, is to add a destination marker. And this one we'll call saw, because we're in the sawtooth wave section. We'll add another one here, and we'll call this one noise, since we're in the noise wave section. And then we need to have our transition markers here. Well, we know that we want to be able to remain in this section, so I will right-click and add a transition to a marker, and I want this to go to saw. Drag that and drop it so that that transition happens at the end of the bar. But then after we've done that, a really important step is to make sure that we assign a condition for this. So we come down here to the deck. We can see that we have a transition condition. We're going to divert our playback to saw if we meet this condition. I want the waveform to be equal to saw. It's just as simple as that. And if you're wondering how these parameters were created, because in this series of lessons that we've done, we haven't done anything quite like this with parameters that have names like this. If I right-click over here, and let's say I was going to do it to add a parameter sheet, or actually, let's just do it this way. Let me right-click and add another transition region. Let's send this one back to sine. Oh, whoops, wrong thing. I don't want a transition region. I want a transition marker. Jump it back to sine. Let's say that the sine condition didn't exist, or let's say that it needed to be something else. Well, add condition, add parameter condition. If I needed to add a parameter, I could click on New Parameter. And the type of parameter that I'm actually using here is called a user labeled parameter. Labeled parameter, we'll just call this example. That's the name of the parameter. These allow you to assign specific labels that are a little bit easier to keep track of than integers or floating point numbers. So I could call this, I don't know, something like first, second. Let's see if I can spell second correctly. Third. And of course you can click add. You can mix those up in whatever order you might want, depending upon how you want them to display. Have something in there that you don't like, you can clear it out. So the add parameter menu is really flexible for adding everything that you need, configuring it in the way that you might want. Click OK, and it will add it to your game, and you'll have a new parameter. In this particular example, I've already done that, so I don't need to do any more. But I do want to make sure that this goes to saw when saw is selected, and that this one goes to sine when add my condition, waveform, sine. And then lastly, we have our noise wave. We want to add a transition. Oh, that's transition region. I want a regular transition to noise. And then I want to also be able to have this transition back to saw. And saw has to meet the right condition, as does noise. All right, so I should have everything that we need at this point. Save this, play it back. All right, so our parameter is square wave. We're locked into that. We change this to sine. I can change this to saw. And it just continues its playback. I can send this back to sine if I want it to. Now, let's try something a little bit different. We haven't played noise yet, but watch what happens when I select noise. It just continues to play through until it gets to noise. And that's something that's important to note about these transition markers. If I ask FMOD, or if the FMOD parameter is at a condition that can't possibly be met in the region that it's currently playing, it will just continue to play on down the timeline until it gets to markers that somehow meet or satisfy that condition, and then the rules of the logic will apply and it will do what we want to. So what that means is that I could set noise as my condition, start playback from the very beginning, and it's just going to blow through all of these transition markers and play through all three waveforms until it gets to noise. And then as soon as it has a condition that it can respond to, it will start to cycle and play back that region. And what that means is that depending upon what you need to do musically, you can structure your arrangement of instruments and sounds on the timeline in such a way that things that need to play in a linear fashion will play in the way that you want to without having to go overboard, adding a lot of rules and transitions and other things that will dictate the playback. And that's really what's great about using these markers and these transitions is that it encourages you or allows you to have kind of a linear, stepwise functionality to your playback. And if that's what your game needs, this is going to work brilliantly. But as with all things, there are many ways to go about doing it. So let's take a look at something a little different. I have a different event here. It's our same basic waveforms, but rather than use transition markers, we're using these green blocks that are called transition regions. They act similarly, but they are done in, or they'll behave. We set them up a little bit differently, and they can give us some additional flexibility and allow us to do a lot more, especially when we're in a situation where we want playback to be nonlinear and to be able to jump from one section to any other section at any time. That's really where these transition regions come in handy. So right now, just to get us started, let's go ahead and revert this to square wave. And right now I can play this back, and square wave is where we are. So I'm kind of locked into this playback, but not because of anything that's listed right here. It's because when it plays through and it gets to the end of this first bar, it hits this transition region, and that says, well, if our game parameter is square, it should go to square, and it just jumps right back to that marker. But the region that we're playing, the region that we're making contact with as we play says to sine. And what that means is that as soon as our waveform parameter changes and we select sine wave, it's going to jump to this marker. I'll change that, and it jumps and it plays it right away. But then, because there's nothing here to stop the playback, it just continues to go unabated down the timeline without much of anything in the way to stop it. That's where some additional work is needed in order to allow each of these four sections to have some autonomy and to give us the flexibility to lock playback into any one of these sections for as long as we might need. So let's go ahead and do those steps. Right-click, and this time I'm going to add a transition region. This transition region is going to go, let's say, to noise. And I want to make sure that we select the right parameter there. And we'll say that this one goes to saw, since we don't have one of those yet. And now we can play this back from the beginning. Yes, and because this one says to saw, it just locks it in. And then as soon as I say for this one to jump to noise, it jumps to noise. But now we're getting this error. It's jumping back and forth because parameter is set to noise. This is sending it to saw. That's sending it right back to noise. It's really just kind of in conflict. We're not completely finished here. We need to mix these things up. And what we can do is start to structure this so that we actually allow these regions to be present in more than one place, so we don't get those kind of conflicts where it just keeps jumping back and forth. So I want to take to square, and I'm going to send that so it goes all the way over. So if I'm playing back in any of these three regions, I have the option to jump back here to our square marker if that's what the game parameter calls for. Oh, and something else I should bring up before I do this, because I'm kind of hiding one of the differences. Notice how these two regions that we started with have these thin little green lines that are there, but these two don't have any. That's because right now, these regions have a quantization interval set. Right now, quantization for square and sine regions is set to be a quarter note. And so you can see that these thin green lines fall on the coordinate grid. whereas noise has nothing, saw has nothing. But we change that, and we can see the grid. We change it to half note, and we only get one line down the middle of the bar. Change it to eighth notes, and we get a different subdivision, and on like that. So depending upon what makes the most sense musically for your solution, a quantization interval will help those transitions come off more smoothly and sound like a logical musical extension of where a phrase or a line was playing and where it decides to go next. So as an example, from the beginning, I'm going to cue this new parameter to jump to to sine wave, but I'll do it early on, and you'll notice that it has to wait until it gets to the next quarter note beat before that transition can actually happen. There we go. So the transition fell. It ended up transitioning there at beat 2 or beat 3, and then it jumped right to that marker and then picked up on beat 1 of bar 2 here and continued to play along. So now that those quantization intervals are set, let me reconfigure this so that we have these regions in every place that we need them to be. And when you have a region that is already in place, you can copy and then right-click and paste, and it will, drop it where you need it to go. I want to put sine there. I want to put saw up there, and then we'll drag sine so it's over there, and saw is going to go there. Copy. Paste it in here. Oops, did it? No. There we go. Just didn't paste it the first time. Okay. So now I have noise throughout all three other waveforms. I have saw here and here, but not here, and it's there. Square is missing there in the square section, but it's in the other three, and sine is absent there, but available in the others. Fantastic. So let's go back to the beginning. Trying to figure out what I did wrong here. Well, I didn't set conditions for some of these. I got so busy moving them around that I didn't reset the condition. So that's going to go to saw. It has to meet the saw condition. So sine to sine, saw to saw, noise to noise. Good. Square to square. Good. Sine to sine, good. Saw, add condition, waveform, saw. Excellent. There we go, now it'll play. All right, so we're at our square wave. Let's jump to saw. There we go. It jumped on, I think that was beat 3. Let's go on to noise. You saw it transition there at beat 2. Oh, but look what happens. Right there, there is nothing to control the playback, and it gets to the end of the event, and it just kind of dies. This is a situation where we can right-click and add a loop region. And what that will do is just allow us to be here in the noise section. And the loop region kind of locks our playback over this bar. But we have all of our conditions, 2 saw, 2 square, 2 sine, all in place. So I can choose 2 sine, and it will automatically jump and send me back to that section. And we have all the flexibility in the world to move around and jump whatever section we might want to go to. Because these loop regions are present throughout the playback, and they will always take us to the destination marker that we defined by name. And that gives us a lot of flexibility for something that we'd probably describe as nonlinear playback, where we're just jumping around from different sections of the song in any order that we might want to. Now, we have another option for doing that, and that is this event. And it's a much simpler, much cleaner way of going about doing this. You can see, rather than have the markers or the transition regions, we have these red bars, and these are called magnet regions. These magnet regions are really interesting because whereas these regions talk more about the act more as a point of departure, this is where you are and we're going to go to sine or to saw or to noise, these magnet regions act more like the destination. So you can see here, I have this magnet region. It's checking the waveform parameter. It looks to see if its value is square. And if square is the value that's present, then as a magnet, it will be, playback will be attracted to this region, and it will go to this section and lock the playback in here. So this is more of a destination than anything else. And you can see the way it's set up is pretty simple. We have sine wave is set to be our destination here. And if we play this back, our game parameter is square, magnet region is looking for square, and it just locks right in. Now, as soon as I change it to sine, you'll see it jump playback, and it will go to the sine wave magnet region. But did you notice that? Notice that when it jumped, it followed the half-note quantization, but in addition to jumping to sine, it also jumped to the nearest half note of this region. So it jumped to beat 3. And you'll notice it'll do the same thing here. If I can cue it at just the right time, it's going to jump again and lands here at beat 3 of the square region. And magnet regions will do that when you have something turned on called relative offset. I can turn that off and play it for you. And we go from square to sine, and it allows the playback in that case to always start from the beginning. Now the quantization will still allow it to jump from the nearest, in this case, half note, but it left beat 3 of this region and went to the beginning of this region. When I turn the offset back on and set it to relative, here we are, but notice I'm going to cue the transition, and it will jump from beat 3 of this region to beat 3 of this region. And that's a really interesting feature about the magnet region, the fact that it maintains this sort of symmetry from one region to the next. It knows how many bars or beats or whatever value you've set for the quantization, and then it uses that as part of the destination when it arrives in the new region. So just quickly to set this up so you can see how this works. Similar to what we've done in the past, we right-click, but we say we want to add a magnet region. Stretch that out to fill the full space, and then, like we always do, add a new parameter condition. And again, because this is thought of, or it's easiest to think of this as a destination, I want to choose saw. This is the magnet region for saw. And whenever the game parameter changes, that magnet is attracted, or the playback is sort of magnetically attracted to this region, and it will snap there. Similarly, we add a magnet region here, stretch that out, and we want this magnetic attraction to work when the condition is set to be noise. So we define that as our parameter. I don't have any quantization here, and that may be good for the sake of example. and it just jumps automatically. But at that point, it just kind of jumped at the moment that I cued it. And musically speaking, that could end up sounding a little bit weird. So this quantization interval is probably a helpful thing to include for magnet regions, especially if you want to preserve the rhythmic integrity of your song. If you end up just jumping at any possible point, you're going to end up losing some beats, and that could sound a little wonky, when all the music comes together in the final playback of the game. So with markers and magnet regions, you have the ability to jump around in a nonlinear fashion, similar to what we found with these transition regions. But as you can see, there's so much stuff that we had to configure here, whereas magnet regions is really clean. It's just these individual regions and the markers. So it can be a much more efficient way to go if that works for the implementation that you're trying to do. So again, to summarize, horizontal adaptive music. It allows you to mix and match the sections of the song and to change the order. And the reason you want to do that is it simply can prevent a set song form from stagnating. So rather than have a song with sections like we have here, A, B, C, D, over and over and over and over into infinity, we could have A, B, C, D, C, A, D, B, B, C, A, D, D, A, C, B, and on and on and on, and mix it up like that. So these examples that we've looked at are, not abstract, but just, pretty rudimentary implementations, but it should show you how the logic for these technique works. Let's take a look at something that has more of a musical focus. And I want to start with this event. And good, this is zoomed in a way that, it's a little hard to see everything. Let's zoom out a bit. Okay, there we go. So this is, this sound instrument right here is a very rough, rudimentary recording of Maurice Ravel's Bolero. I did this in Reason, using the default Reason instruments. So the samples are not great. They're okay, but Reason's orchestral sample library pales in comparison to a lot of others that are out there right now. But it's a functional way for me to put this demo together. It allows you to hear the song. And part of the reason why I thought it would work so well for this lesson is simply because Bolero is all about development. It's all about taking this little kernel of a musical idea and developing it as the melody is passed from one instrument to the next, as the orchestration changes and you hear instruments playing in different combinations, trading accompaniment for the melody and round as the intensity of the piece builds towards the end. Now in this example, I only go through the introduction and the first 5 statements of the melody. So you hear a flute, a clarinet, a bassoon. I think the next one is technically an E-flat clarinet, but it just sounds like the clarinet up an octave. And then the last section I have here is the oboe. And with this implementation using markers and transition, destination markers and transition markers, this keeps Bolero in a pretty linear place. The only exception to that is right here at the beginning, where I have a transition region. So when we're locked into the intro here, just kind of waiting for playback to start, I can jump into the melody at any point, and I have this quantization set to be every bar. So imagine the player gets started, and the game cues the first section or the first parameter, and we move on to the first statement of the melody in the flute. And the flute plays along and does its thing, and then at some point conditions in the game will change, and that parameter gets updated, and we move into the next section, which is, in this case, our parameter is Orchestra Advance, or Orc Advance, and now it's looking, and it's allowed to keep playing back here because this transition marker just simply looks to see if marker A is what's set, and if it's not, playback continues. Well, watch what happens here. I've set it to be C, and there's a 2 marker C right here. And so it immediately jumps to the bassoon melody, even though it was only partway through the statement played by the clarinet. And that's because I had a transition marker there. And because that parameter condition was true, and it ran across the marker, it jumped at that point. But if I leave it here at parameter condition C, and allow the bassoon to continue to play, its playback will march on, and you can see it's moving towards another transition marker that says go to C. Well, C is still true, and so it jumps back to marker C, and we're back into another statement of the bassoon again. Let's just look at how that could work again. I've set the parameter to be condition B. You can see it's coming up on a transition to marker B. And those markers just fall right in the middle of the phrase where it makes sense to transition. The melody, as written, goes on for several more bars, but that's not something that needs to happen in the world of game audio, particularly with a horizontal adaptive technique like we're doing here, where we want to mix up the statements of this melody. So I have the ability to jump from section A to B to C to D to E, and also with the markers configured in the way that I have here, I also have the ability to make those transitions happen in the middle of the phrase, so I don't necessarily have to wait until the end. I mean, ultimately that decision is up to you, the composer, based on what you wrote and where you think it's musically appropriate to transition from one section to the next. But this approach in FMOD allows you to mix and match the order of the sections, following that horizontal idea that we started this lesson with. But it's doing it in a way that kind of follows the phrasing of this piece and still allows it to have something that is very much in keeping with the character of the original, but without having to wait for an additional 8 bars until it gets to the end of the next melodic statement, and jumps to a new melodic statement by a different instrument. So I've done a few other versions of Bolero with some of the other techniques that we looked at earlier. Let's just go ahead and go in the same order. So here's a version of Bolero using transition regions. And you can see I've got the same sort of stair-step configuration of transition regions. So we can't transition to marker A when we're playing marker A. We can't transition to B when we're in marker B, etc. for all these others. I have loop regions set up for these individuals just as a way to make sure that playback is locked in each of these sections. And the reason why I had to do that is because you'll notice that this event is a whole lot more complex. Here in the timeline, I'm only stretched over only 6 bars. And as you know, Bolero is a whole lot longer than 6 bars. But if we go back and look, here I am, 177. How many bars do I have? 184? Yeah, there's a lot there. Well, I was able to condense this into a much shorter event in the FMOD timeline by working with events that are actually embedded in these other instruments. So it's a nested event. If I double click, we can see here I am inside this other instrument. I put all of those in a folder called sections. So this is 18-3 bassoon flute. So it's this, where is it? Bassoon flute, why can't I see it? Oh, that's the name of the, that's the name of the instrument, not the name of the instrument. Yes, this is the name of the sound file. 1803 bassoon is the name of the instrument. Pardon my confusion. All right, so here I am. We're looking at it on its own. If I'm back in the event with regions, I'm here, and if we double click on it, this display in FMOD kind of helps make it clear how there's a hierarchy and that this event is really a sub-event of Bolero regions. And it just takes this stem from the song with just the bassoon and the flute and allows that to loop. So when we're here inside this event, get back there, it's referenced, and because the sound file that is inside of this event is set to loop, it will play through its full duration, but here in FMOD, it's just looping in the span of a single bar in this timeline. So you can see that playback loops right here between beginning and end of bar 3, but this little playback needle allows you to see exactly where it is overall in the duration of this event's timeline. And because I've set this up with transition regions, I can go to any other section of the song and jump back in this case and hear just my flute melody, or jump back even farther and go to the intro. And you'll notice that all of these transition regions have a number 1 listed right there. That's because the quantization interval of these is set to be 1 bar. That was the interval that just made the most sense, I thought, for this. There's moments when it's not ideal and I wish the transition would wait a little longer. And I suppose with some more wrangling in FMOD, I could find a way to allow those to happen a little bit more gracefully. But for this lesson, I didn't want to go to that extent. I just really wanted to allow these sections to be accessible at any point in time and give this event the flexibility to jump from the intro to A, B, C, D, or E in whatever way the game events might dictate. And so that's how this works with transition regions in FMOD. And then as you can see, and probably we're expecting, we have similar thing set up here in a new event with magnet regions. And as you probably would have guessed based on what we've seen before, this is a whole lot more clean than what we saw before. I'll zoom in like this in order to make it a little bit more clear. Let's do that to squeeze out a little bit more space. So what's going on here? Well, with these magnet regions, again, the magnet region is best thought of as a destination. So this is the beginning of section A, and we're sending this to section A. It jumps to this marker. We've got this magnet for B, and in fact, these markers are only really there just to be able to see where these sections start. We're not really even using marker A, B, C, D, or E at this point. It's really just the magnet regions. But they don't have any labeling on them, and it's nice to be able to see where everything is, I think. The other thing you'll notice is that in order to make the intro accessible at any point, we have a transition region here at the beginning. The reason why we couldn't do that with a magnet region is because all of these sections are 18 bars long. And so if we have relative set to be our offset, and we're in a bar value that exceeds what's in the intro, I just found that the playback got a little bit weird, a little wonky at times, so this seemed like a safer way to go to make sure that intro would always jump to the beginning. So you can probably anticipate what this is going to sound like, but we'll just go ahead and let it go. And let's jump to section D. Quantization is set up to be a full bar, so it waited until we got to a bar. And now, as I jump to another section, you'll hear the melody transition mid-phrase. It doesn't always line up perfectly because the phrasing of these individual sections is a little bit different from one to the next, but the process is mostly pretty seamless, and we can jump back to the intro at any point that we might want to. And this is a far faster way to put something that is horizontal and also nonlinear together. Now, musically speaking, this may not work given what you want to do, but for situations where you can jump around and specifics of phrasing may not be absolutely critical, this could be a really slick way to go for your particular implementation. Well, now that you've seen how all of this is put together in FMOD, let's switch over to Unity and look at how you would work with game components and a little bit of C# code in order to implement this in a Unity game. So we're in Unity now, and at this point, assume a couple different things have happened. We have our Unity project. We've integrated FMOD. You can see here in the FMOD studio settings, I have my project path set. All the events are there. I've got, I'm not using the events with the sine waves that we saw earlier. Those are just for example, but I've got the 3 different techniques of Bolero that we'll be able to test out here. And the FMOD project, of course, saved it, built it so that everything that was done over there is now available here in Unity. Well, I think the best place to start in terms of implementing this is, well, actually, let's look here. So we've got a vehicle with FMOD Studio event emitter attached to it, and I'm going to start with the markers event. So we'll go through and use a linear path. You can see that we have the parameter orc advance like we did before. But one thing that was a little frustrating is to see that rather than get the very easy to use and intuitive names like intro, A, B, C, D, E, here we just have a bunch of, we just have floating point numbers. Now, fortunately, we have the right we have the right number of numbers. So intro is like 0, and then A is 1, B is 2, C is 3, etc. And we'll use that in C# in order to jump from section to section. But those user, switch back to FMOD, what's it called? User labeled parameters that we had here in FMOD that were so helpful just don't show up in Unity in the way that, well, at least I personally would like to see them. And if anybody watching this video has any idea how to do that, please put it into the comments below. But scouring forums and FMOD documentation, I couldn't find anything that made that clear in any way. But we can still get it all to work. And like I said, C# is in a lot of ways kind of the best place to begin. So what do we need? Well, to a certain extent, some of the code that we use builds on what we did for our last lesson, where we were doing a basic interactive music implementation with an intro, a loop, and a tag. And we had those three different sections. As we crashed into obstacles, we had this variable that would tally the number that we hit, and every time we hit a new one, it would add something to our existing music. Well, for this implementation, we're going to do something beyond that, and that is we're actually going to track which obstacle we hit along the way. And I'll talk you through how that works when we get there. But we have this public integer that I call hit ID. We start with 0, and we'll bring that out and use it a little bit later. But for this first implementation, using the markers, we can really just kind of focus on a few really basic things. So I've got a lot of code for some of the other events commented out right now, but just note that we're here with our Ontriggerenter function. When we hit one of the obstacles, we first check to see if that is in fact what we hit, and then if we do, we increment the count variable and then use the value of count to set the parameter for game music. And again, orc-adv or orchestra advance is the name of the parameter that we're using. And just to review game music, this was from the previous lesson. That's something that we identified up here in our awake function. We retrieve the studio emitter component from this game object, save a reference to it here in game music, and then we use that reference here in order to set that parameter. So from a coding point of view, things are pretty simple with this first implementation. So we're here in Unity. Everything should be ready to go. I can start the game. And one thing to keep your eye on is the count variable over here. You'll notice that as I hit these crates, that starts to increment. I hit the first crate, it goes up to 1, and our flute plays. Now, in the interest of time, because this is kind of a slow song, I'm just going to drive all the way down to the end of the block. And I'm going to hit my second crate. But I didn't hit it in time to trigger the next melody. So we've got to wait for the flute to play and finish its phrase before we can go on and hear the next instrument. That's coming up here in a couple bars. But we get it. So we get our clarinet, and I hit another crate. And so this time, mid-phrase, we'll hear the clarinet transition to the bassoon. Oh, it looks like I double hit a crate. So count is actually set to 4 right now. And then we get to our bassoon. Well, one thing that I put into the C# code that can make these double hits less of an issue is this line right here. I just comment that out. Other.gameObject is the reference to the crate that we just hit. And if I use the setActive method, setActive to false, it will actually just disappear from the screen. And that will absolutely make sure that when we hit these things, they, well, just go away and we don't get any double hits whatsoever. So that little line of code might be a helpful one for you if you want to avoid that. You'll notice I hit it, the crate disappeared, and my count is only at 1 right now. And then now count is at 2. And mid-phrase, we're going to transition from the flute to the clarinet. Just like that. And let's go ahead and drive all the way down the block. And our clarinet's doing its thing. Let's go ahead and hit another crate, which sends our count up to 3. And it means that when we get to the end of this phrase, we will transition and move on to the bassoon. And I'm glad that this is such a long road, because these phrases take a long time to kind of unfold. I'm going to hit this last crate. And when this bassoon is done saying what it needs to say, we'll transition and we'll hear another statement by the E-flat clarinet. And on through the piece it goes. So, based on what we heard in FMOD, none of this really comes as a surprise, but we can just see and hear how it all comes together in the context of a game here in Unity. So, with that in place, we can make a couple changes to our code and start working with a different event. We started with the markers, so let's change that up and move to regions. So I can just swap out the event that's there. Because we use the same parameter and it has the same values, we really don't need to worry about anything else that's here. And just save that and then switch back to Visual Studio and take a quick look. Is there anything else that I might want to do here? Well, there will be, but that should be just fine for now. And I'm going to go ahead and let those objects disappear, just so we don't get any double hits. But let's go ahead and just take a long drive down. Now, again, because we're working with transition regions, we're going to get much quicker and much more responsive transitions from one section to the next. Another thing that's worth noting is that the instruments come in a different order in this version. We went from the flute to the bassoon, and now we're listening to the oboe. I'm going to clear away another crate here, and we'll go to the saxophone. And after the saxophone, we get the piccolo. So things play out much the same way that they did before. And again, the biggest difference, of course, is the fact that I put the instruments in a slightly different order. So like I mentioned earlier, we start with the flute, then go to bassoon, then the oboe, then the saxophone, then the piccolo, at least as the instruments that kind of carry the lead line. But because we're working with transition regions in FMOD, we hear those changes much more quickly, and the overall shift is more responsive. Now, arguably, it doesn't preserve the character of Bolero as well as some of the others, I would say. And if I was going to do this with Bolero, I probably would approach this differently than what I'm doing right now. But for the sake of example, it's good to hear that, even though it may not be the best sounding way to approach this particular piece of music. Well, one of the other things that the horizontal technique with transition regions allowed us to do is to jump freely between sections and have options for nonlinear playback. But right now, we can't really do that because the way that we're tracking our progress in the game is to go through in a linear fashion. Count starts here as 0, and then every time we smash into an obstacle, count is incremented and that new value is applied. So we're going to go through 0, 1, 2, 3, 4, 5 every single time. If we want to be able to go through in any order, we need to give each crate a value so that when we smash into the crate, we can retrieve that value. So smash into crate number 3 and we hear the oboe. Smash into crate number 1 and we hear the flute, so on and so forth. And we can do that. We just need to write a little bit more code in our game. So let's go back to Unity, and I'll start with this first obstacle and add a component. I'm going to add a new script. And just for the sake of consistency, let's all name ours the same thing, which is capital M music, capital S section. So I have a new C# script named music section. By default, it's just going to drop that anywhere here in our assets folder, but in the interest of keeping everything tidy and being able to find it later, I'm going to drag it down and drop it here in the scripts folder. So even though I've moved that, you can see that it's still attached here to our first obstacle. And now that we've got it there, I'll double click, open it up, and it puts it here in Visual Studio. This is a very simple and unassuming script. And we don't need start, we don't need update, we can just clear those out altogether. All we need to do is create a public variable. It's going to be an integer, and we're going to call it section. That's it. Public int section. That's all we need. Save it, and then we can switch back to Unity. And you'll see now, if I highlight that first obstacle, music section script is there, but because section is a public variable, it's exposed here in the inspector, and we have the default value of 0. Well, I'm going to go ahead and change that to 1. And then I need to do the same thing for all of these. So I can select all of these as a group, just shift click, and I can drag that script and drop it on all of these. So now music section exists on all of these, which is helpful. But then we need to configure the value for section. So I'll just go through sequentially and add the values 2, 3, 4, and 5 to the subsequent obstacles. So my last obstacle has a section value of 5. The one before that is 4. The one before that is 3. One before that is 2. One before that is 1. So now each obstacle has this little bit of data attached to it. And what that means is that I can then retrieve that from the player controller script and then use that to direct where our timeline jumps in our FMOD event. So if I'm going to do that, I need to get rid of these lines. Well, not get rid of them, we'll just 2/ characters to comment them out. And then I'm going to toggle on a couple different lines here in my script, and I'll go through this so that you can actually see this up close and copy it into your own code. So let's look at this whole function. Oh, and I don't want to make these disappear. Now I want those crates to remain because I can hit 5, then hit 3, and then go back and hit 5, and allow the song to bounce back and forth between those two sections. If the crates disappear, I've lost the ability to do that, and it makes all of this kind of a moot point from the beginning. Make sure I didn't forget anything else. Nope, that's everything I need. Okay, so let's talk about this. First line, line 50. This is where we get the data that we need from the game object. We retrieve the data that we need from the music section script, and it's referenced by this music section object. Then we use that hit ID variable that we talked about earlier. We created that at the top of our script. Hit ID is a public integer. If you missed it before, public int hit ID is right there. And just initialize that with the value of 0. Oops, let me come back. But then we take the value from that, the value that we retrieve on collision, which is called section. We get that from our game object and then assign that to hit ID. And then a line that should be familiar to you now, we just plug that value in as a value for our component. It's setting, I'm sorry, not component, value for our parameter, and it's setting the parameter for game music, just like we did down here with our count variable earlier. It's just that rather than work with an incremented value, we're going with whatever value we may have retrieved from the object that we just smashed into. So I'll save that C# script, switch back to Unity, make sure everything, and no errors or anything like that. Make sure, yes, Bolero Regions is selected. That's good. That's exactly what I need. So I can play this. And just for the sake of example, let's go ahead and ignore these first few and just jump right in with our last section where we should hear the piccolo. Yep, and there it is. Come back here and let's hit this one, which I think is going to give us our oboe. Yep. Back to the beginning with our flute. And it's doing exactly what we heard in FMOD, jumping from any section to any other section, but with all the flexibility in the world. And you'll notice the hit ID variable is exposed in the inspector over here. So as soon as I smash into this next crate, you see that update. Value of 5, so just hit crate 5. We'll come back here and hit crate number 3. It updates the value and switches and allows us to hear the section of the song with the oboe. And so last, just for good measure, we can do all of this with our implementation or our event that use magnet regions. So switch out the event. But that's really all we need to do, because in our C# code, we're retrieving the number from the box that we hit. That box goes to our parameter. Nothing has changed with our parameters from one event to the next, so all of that can remain exactly the same. But what will be different is the fact that these magnet regions are going to jump right in the middle of the phrase. So we leave our intro, and it ends on the bar, and we have our flute, and then we'll jump right from the flute to the oboe, mid-phrase, right into our piccolo. So things are working exactly as we would expect them to. And those magnet regions are going to give us really, really tight and precise shifts from one region to the next. They may not be the most musical sounding implementation of Bolero, but with a different approach would probably work best for this song. And ultimately, with the right music or the right instrument structure in FMOD, all of these techniques will be able to employ successfully to give you horizontal adaptive music that has some truly seamless transitions and allows that song to flow from one part to the next as if that was the way that it was composed from the very beginning.